Trail and ultra runners, what is going on? What's happening? Welcome to another episode of the Koopcast. As always, I'm your humble host, Coach Jason Koop, and this episode of the podcast focuses on the limits of human metabolism and how those limits might ultimately be the deciding factor on what the upper limit of ultramarathon performance actually is. On the podcast today to enlighten us is the dynamic duo of Herman Pontzer and Andrew Best. Herman is a professor of evolutionary anthropology at Duke University, where he focuses on the evolution of human energy expenditure and metabolism. He is also the co-founder of the Human Evolutionary Ecology Lab, where he and his team study the effects of diet, physical activity, and modern environments on human health and disease. Herman's latest book, Burn, The Misunderstood Science of Metabolism, and a link to that will be in the show notes, is an incredibly intriguing read. And in it, he explores the latest research on metabolism and challenges long-held beliefs about weight loss and metabolism, so much so that when reading that book, and at times during this interview, you will be certain to have a head scratcher or two, and if so inclined, like I am, head down the proverbial research rabbit hole. His work has been featured in numerous publications and media outlets such as the New York Times, the Wall Street Journal, NPR, blah, blah, blah. You guys get the idea. But more important to our audience of ultramarathon athletes is how metabolic scope, or the amount of calories you can expend above your basal metabolic rate, might be the ultimate limiter of ultramarathon performance and influence your training. His colleague, Andrew Best, is a biological anthropologist and assistant professor of biology at the Massachusetts College of Liberal Arts. He's also a respectable endurance athlete in his own right, and Andrew is currently conducting a research project on ultramarathon and ultra-endurance athletes that further tests the limits of what this human metabolic scope might actually be. This was a project that I just happened to be a subject in during my training and racing for the Cocodona 250 earlier this year. And so I decided to bring on Herman and Andrew to the podcast today to see what we can learn about their work and how it can inform our training and racing. All right, that's enough of me blabbing. I'm getting right out of the way. Here is my conversation with Herman Pontzer and Andrew Best. So first off, thanks you guys for coming on the podcast. I appreciate it. And especially for Herman, if you're going to be on sabbatical soon, we'll try to get this out of the way as quickly as possible so you can go and write your next book and, start getting on. Are you into it already?
Oh, yeah. Yeah, sure. Yeah, you can't, they give you the deadline we set is next year, next December. So I've got plenty of runway, but that's, good and bad, because if you have a deadline that's way far off, it feels like you have forever, and you don't really. So, but I'm into it.
Is it going to be related to the last book, like some
yeah?
Sort of
so it's another book about how your body works. Only now, instead of just looking at metabolism, we're looking broadly across all the different systems in your body. But it's again the sort of evolutionary lens on how the body functions. And the key piece of it is there's a few books out there that try to do that already. But this is how your body works relative to everybody else's, like why we're all different. How sort of individual physiology happens. So not just how your brain works, but why some people's brains work different than others.
Well, so this will be a good launch point, and I told you I'd deviate from the outline at some point, so we'll kick it off with that. Sure. How did the first book come about? Because it was wildly successful, and this is one of those things that you pitch to a publisher. Yeah. And I know a little bit about this world. You pitch to a publisher, and sometimes they're like, man, I don't know. Like sometimes these science topics don't go over very well. But how did it all come about?
Yeah, I mean, I've been working in metabolism for 15, 20 years now. So it's material that I've been kind of generating myself, over the years with research, and some of the surprising results from that, kind of sparked people's interest. And I had people reach out to me about, hey, well, you should write that up for a broad audience, either as an article, a magazine article, or maybe as a book. And so I got thinking about that. And that kind of just snowballed into this opportunity to write Burn. And that's how that went.
Well, congratulations.
Yeah, thanks.
Because you like I said, sometimes those science books, they either go one or two ways. Either they're successful or they're just not, and they end up sitting on the Amazon shelves collecting dust. So Herman, good job with that. Yeah, Drew, take a second to introduce yourself and how you got involved in the mix here.
Yeah, I was trying to remember how I first approached Herman because I'm sure it was me. It's probably 2 years ago or something. But so I'm a late bloomer. I taught high school biology for 15 or 16 years, and went back to become an anthropologist during that time. So most of my background is teaching, and the research really is new to me in the last 7 or 8 years. Um, so I guess the things I'm into, evolution of sweating. My dissertation project was all about variation in sweat gland density. How many sweat glands do we have? Does it matter? Spoiler, I don't think it matters. That's a different topic. And really all along the way, I've been interested in the evolution of endurance physiology. Why are we built to move? The Dan Lieberman stuff, the Herman Pontzer stuff. And so I think at some point, I probably reached out to Herman via Twitter or something with some question. And we chatted a few times, but then I think it was probably when Joe McConaughey approached me a year or two ago. I met him in a race. Quick tangent. Joe's a super nice guy. He obviously beat me in that race because he's very good and I'm less good. And I'm chatting with Joe and his now wife, Katie, after the race, and they're asking me all about my running. And of course, I'm pontificating. Oh, I've done this and that. And he never even told me, what his deal was. He had just set the record on the Appalachian Trail. So, and I found that out later, and I was like, Joe, how did we not talk about that? That's incredible. So he reached out and said, look, I want to get some data. Sorry, my dog's barking in the background. And he said, I don't know what data to get, but I'm doing these crazy things. Let's study it. And I was thinking, well, I need a new research avenue. I was just about to take my current job, my first faculty gig, and it's really teaching heavy. So I needed a research direction to go into where I could collaborate with other people, do it mostly in the summers, do some writing, during the semester. That's really all I have time for. So I said, well, Joe, I don't think I can do this stuff, but I know some people who can. So reached out to Herman and a few others, and here we are.
Oh, sweet. So we're going to talk about the research project that I'm a subject in, and we can divulge into that data at some point. But why does ultramarathon and not just ultramarathon, but ultra endurance keep popping up in you guys' work? I mean, I know that it serves as a blueprint for a lot of what we can understand about the human body, but in your words, why is this so important to look at it through this specific ultra endurance lens?
Yeah, I'll kick that off. So, we study human evolution in my lab, human metabolism as well, because, the way that our bodies burn energy is where the rubber hits the road in terms of evolutionary biology, right? Life is a game of turning energy into kids. And so, that's really the nexus of evolutionary biology, is where it all happens. So if you want to understand anything about an organism at all, understanding how it burns its calories is a key piece of information, because everything your body does, from movement, of course, to growth, to reproduction, brains, immune systems, it all takes calories, right? So when we measure energy expenditures in my lab or for any kind of research project, we're getting the whole budget for somebody's body, right? How many calories came in and how many calories went out. And so I've been studying metabolism from that perspective, that evolutionary perspective, for a long time. And we've had some really fun results that made us rethink of what we thought we understood about how metabolism worked. One of the key things was about 12 years ago, with Dave Reichland and Brian Wood, a couple of good friends and collaborators, we went to measure energy expenditures, daily energy expenditures, how many calories your body burns every day, with a group of hunter-gatherers. It's a community called the Hadza. They are in northern Tanzania. They don't have any domesticated crops or animals or machines or vehicles or electricity. They live in grass houses in the middle of the savannah, and they get more physical activity in a day than most Americans get in a week, right? And that's the kind of lifestyle. I mean, we're all modern humans today. There's nobody who's sort of stuck in, nobody's a time machine. But if you have a culture that has those kind of elements to it, that you're hunting and gathering, that's a way to ask the question: what does hunting and gathering do to our bodies? How do our bodies work in that kind of an environment? Because that's the kind of environment we evolved in, right? So as an evolutionary biologist, a human evolutionary anthropologist, that's the kind of thing I'm interested in. And so we went there, we measured daily energy expenditures with this technique called doubly labeled water, which is this really accurate, reliable technique for measuring total calories burned over about a week-long period. We knew going into it, we'd see really high expenditures because, like I said, these men and women are really physically active. It takes a lot of walking and other work to make a living on the savannah, right? With literally hunting with bow and arrow or digging, wild tubers out of the ground. These people work so hard.
They work for a living.
They work for a living, literally.
They work for a living, yeah.
That's exactly right.
Which very few of us actually do.
No, that's exactly right. And so, and that's, again, that was kind of, from an evolutionary perspective, that's the data point you need. And the huge surprise was that their total energy expenditures are the same as typical Americans, right? So super surprised by that. They're burning the same number of calories every day as folks in the US, Europe, Japan, other industrialized countries. And that tells us, wait, the body is doing something really phenomenal here that we hadn't appreciated before, that lifestyle kind of doesn't push things around like we think it does, that, at least up to some point, up to some pretty high level of activity, your body can adjust. The more active you are, it seems to change the way your body burns calories more than it does the number of calories you burn every day. And of course, that constrained view of energy expenditure is a big surprise. It changes the way we think about how exercise affects our bodies, affects our health, and lifestyle affects metabolism, energy burned. But then the obvious question is, well, are you telling me, right? This is the question I always get. Are you telling me that Michael Phelps, swimming God knows how many meters he swims a day or a week or whatever, are you telling me an ultramarathon runner who is running 100 miles a week or whatever it is, are you telling me really that they're burning the same number of calories every day as somebody sitting behind a computer? And so the answer is no, there must be some limit, right? There must be some limits on this constraint. There must be some metabolic ceiling, or maybe there's a metabolic ceiling. Maybe you can push, maybe anything's possible if you push hard enough, we don't know. So then this question about what are the metabolic limits? What are the limits of endurance? How does it all fit together? That becomes the obvious set of questions to ask. And that's why I love this research so much, because it's kind of, for me, it's the obvious next thing to ask. Okay, well, the body seems to adjust to lifestyle. What are the limits to that? How does it actually work out? And people are really pushing the body to its extremes.
And the ultra marathon crowd, the ultra endurance crowd, happens just to be very good candidates for that. And we're going to talk a little bit about the research project that Drew's involved in a second. But to set this up, since we are going to talk about human energy expenditure, and we're going to have predominantly a lay audience here, let's give a freshman level overview of what the buckets are in terms of how we can how we can choose, or how we have to spend our daily calories as humans.
So you've got 37 trillion cells, and every one of them is a little microscopic factory that's bringing stuff in, dealing with it, and putting stuff out, right? It's every cell in your body is active every day, chugging along, burning calories. And we can think about each system in your body then as sort of a department in this big business that we run, that's our body, right? They kind of think of your body as a business. Resources come in, work gets done. And all that process, that energy burned on that is what you call your metabolism. And so every system in your body is burning calories, right? And so if you're at rest in the morning and you're just completely laying there flat, not stressed out, anything like that, your organs themselves are burning what we call your basal metabolism. That's like all your departments at their lowest level of energy expenditure. So your brain, digestion, immune system, all that stuff at its lowest level of expenditure. All of that just background baseline stuff that uses up about 60% of your energy, let's say 60% of your energy every day for the typical American. Is most of it spent on that. The rest of the energy you burn every day is a combination of things like movement, exercise, even muscle activity that you wouldn't think of in terms of like standing up, right? The postural muscles take energy. And then things like thermoregulation, staying warm or cool, stress has energy cost, right? Your organs themselves have a kind of circadian rhythm, like kind of like they're more active during the day than they are at night. And so there's also this sort of less well understood component of circadian changes in cell activity. But those are the big buckets: your organs at rest, your muscle movement, and then some in between stuff that's a little bit harder to get your hands on.
And so what's the theory then? Since you've been studying all of these extreme populations, what's the theory in terms of how much energy expenditure can we either fluctuate or live by day to day? You're probably going to be able to describe it better than I'm setting it up here.
So the typical American burns, between 2,400 and 3,000 kilocalories a day. Men burn about 3,000 kilocalories a day. Women burn about 2,400 kilocalories a day. There's variation around that. Most of it's based on size. You can be more physically active, and it doesn't necessarily change that number, right? And so what's happening? Well, if you're more active, it seems like we're spending less energy on all the other systems that our bodies are active with, right? All the other systems that our bodies burn calories on. And so we're actually trying right now in my lab to figure out what all those sort of levers you can pull to take energy away from this system, because you're using it on activity rather than on, let's say, immune system. Here's what we know now. We know that if you are a runner or any kind of athlete, you're burning more energy on physical activity than somebody who's sedentary, and that's good for you. You should do it anyway, even if it doesn't change your total calories burned. But people who exercise regularly have lower levels of inflammation. So inflammation is immune system activity that your body doesn't really need to do. Chronic baseline inflammation that's high is bad for you, and that's your immune system sort of running unnecessarily. Those are calories you don't need to burn. People who exercise more don't respond as dramatically to stress. So their heart rate goes up less and it comes back sooner than someone who doesn't exercise. So you're saving calories that way, we think. Reproductive hormones seem to be in a healthier place. And so like the testosterone, estrogen levels you can overtrain to the point that you can actually suppress them to an unhealthily low level. But for people who exercise, they tend to be in a healthier range than the sort of higher ranges that you see in sedentary people. So we can kind of see where the body is saving energy. We don't have the story sorted out yet. So this is sort of in process work.
And there are going to be a lot of athletes out there that listen to this and say, wait a minute, you're telling me that whether I sit on the couch and watch Netflix all day, or I go do a 50-mile run, you're telling me that I don't need to eat I can't eat anymore, because that's usually people's excuse to, go out and run, is so they can have an extra, helping of Thanksgiving turkey, since we're recording this just after the holidays. So explain that nuance to people, because that's what everybody's thinking right now.
That's right. So the more physically active you are, the more you exercise every day. It doesn't seem to change the total calories you're burning very much. And so it really doesn't give you a lot of extra cushion to eat more, right? And it won't affect the extra cushion that we're all carrying. That's the bigger issue, right? Exercise ends up being a terrible way to try to lose weight. It's great to do anyway, but we've known this for a long, long time, not just my work, but we've known this for decades, that exercise isn't a great tool for weight loss. And that's probably one of the reasons why, is that there's other things that go on too, but one of the things that happens is your body adjusts to your new lifestyle, and you're not burning as many calories as you expected to based on your exercise program.
So let's enter how we are actually trying to figure this out, right? Yeah. And we'll point to some more recent work that Drew is kind of undertaking right now. Do you want to take a moment and just set up the study that you're looking at right now, based on this genesis of talking to String Bean Joe and coming up with this idea that we're going to study ultramarathon runners?
Yeah. So to piggyback on a few things Herman said, so why ultramarathoners? I guess one is because Herman and I think it was a Caitlin Thurber paper, right? 2019. It's sort of the big paper that, for me at least, has kind of laid the groundwork for what we're doing here. So they found a pretty strong relationship between how long you're putting out some kind of metabolic effort, right? So that could be running, say, and basically how many calories you're able to burn during that time. So the longer that you're going all out, the slope goes down. So basically, we call it metabolic scope. We should probably mention that at this point, right? Yeah. So Herman talked about your BMR, your basal metabolic rate. That's the total calories it takes to run your organs and, stay alive. And the energy that you spend on physical activity is the top slice of that pie, right? So metabolic scope then is your total energy expenditure that you spend in a day. So basal metabolic rate, the cost of digestion, fidgeting, walking, and if you're a runner, all the running you're doing, that total number divided by your basal metabolic rate. So it's a multiple of your basal metabolic rate. So it's really a measure of how much extra calorie burn you have over and above your basal metabolic rate. So what Herman and Thurber's research really pointed out is that there's this really strict relationship, it seems like, between how long you're doing some kind of physiological effort and the calories you can burn or the metabolic scope you can sustain. So we're looking at ultra runners for one reason, to get more data points for that regression, right? To better elucidate that relationship between the event duration and metabolic scope, really the metabolic ceiling that you're limited to. And the other reason is, to start testing some of these, I should say, further test one of Herman's big questions, which is, what are the limits of human energy expenditure? What is that sustainable metabolic ceiling? How many calories can a person burn every day before they start to dig into, their fat stores and, break down muscle protein and stuff? And that becomes relevant to ultra runners. But we look at ultra runners because hopefully they're doing a big training volume, right? So these are people who are sort of dedicating their lives, as you guys really do, to the pursuit of really maximal energy expenditure. So for the same reasons that we need to be careful using modern athletes as a proxy for, here's how humans evolved. I mean, we're fairly unusual, right? There's probably a self-selection going on. We tend to be from Western industrialized countries. We tend to have enough time and money to devote to training, unlimited, nutrition, all that stuff, running way more miles than any early human ever would have. Those same reasons also make ultra runners kind of perfect for asking these questions. It's almost like a natural experiment where we've removed all these other variables that could be limiting energy expenditure. And these are people who might be butting up against whatever that absolute limit is, all other things sort of being removed. So that's why ultra runners.
And it's elective too. That's other thing. We're choosing, we don't have to, because we don't have to dig tubers out of the ground, Herman, to your point earlier. We're choosing to do this out of, whatever. I like doing it. I want the challenge or whatever. I guess my point is it's voluntary.
Yeah. And just to jump on what Drew said there. Yeah. So to put some numbers on this metabolic scope, this metabolic ceiling that we think we all live under, if you run the Western States 100, right? I think the fastest people do that in 20 or 22 hours or something like that. And for that time, for that 20 to 22 hours, you can burn about 8 to 9 times your metabolic scope, I think is the number. You come down to the Tour de France, which is 24 or 28 days long. I think it's changed a little bit over the last couple decades. Anyway, for that long, right, about a month, you can do 4.5 times your basal metabolic rate. Your metabolic scope is 4.5. And so if you go out further, we had people who ran from Los Angeles to Washington, D.C. over 5 months. They were burning about 3 to 3.5 times their basal metabolic rate for that amount of time. And the longest duration, highest expenditure thing we've ever measured is pregnancy, which isn't an ultramarathon event, but it kind of is, right?
Yeah, way harder than ultramarathon event. We got to give the ladies some credit since this is all dudes on this call here.
Absolutely. And so, when I said this to my wife, I've got 2 kids, and I was like, guess what? Women in pregnancy are burning this, it's just as hard as the Tour de France. And she was like, yeah, no kidding.
It's like no shocker. Like no shocker.
Yeah. But for something like the Tour de France, to Drew's point, we know that in some way that must be a limit, because if you could burn, I forget what the number is exactly from the Tour de France today, but let's say it's 4.5. If you could do 4.6, you'd win the Tour de France by 3 days.
Right.
If you could do Western States at 12 times your basal metabolic rate instead of 8, you'd do in 15 hours, right? So like you know from the people who are like yourselves, who are pushing it so hard on these ultramarathon events, they are the perfect test of this limit, because it really does, because obviously people would love to break that ceiling. They'd love to be in the space that we haven't measured anybody yet, that's above the ceiling.
So
Actually,
yeah, go ahead, Drew.
I just wanted to pick actually something Herman said I think might be really interesting to point out, and this might be contentious, but so I feel like in endurance performance, especially the longer the distance, it's really a game of who can expend more calories, which we don't usually think of it that way. But I think differences in economy or efficiency between athletes are probably not sufficient to really explain differences in performance over a really, really long distance. And if any physiologists are listening and I'm totally wrong, write in and tell us. But so it's as Herman was saying, the difference between a metabolic scope of 4.5 in the Tour de France and 4.6, that person who can maintain a 4.6, that really would be the key. That it really seems to be that is the limiting factor. The longer you go, it's not, muscle damage. It's not VO2 max. It's not lactate threshold. It's nothing like that. It's actually about expending more calories. So a lot of the training you're doing isn't just to make yourself more efficient. It's actually really just to develop a bigger sort of metabolic engine, not in terms of oxygen consumption, but in terms of fuel substrate availability and the availability to just continue breaking down carbohydrates and fats. So it really is that metabolic ceiling. It really is about burning more calories, which is not a way we often think about it.
Well, and once again, I'm coming at it from a coaching perspective, right? Looking at what an athlete's limiting factors are in any type of endurance endeavor is one of the very fundamental starting points of trying to analyze what you should actually do with that athlete. What kind of training should you do? Should you run long? Should you do sprints? Should you do this type of interval workout? Should you train 5 days a week or 7 days a week or 100 kilometers a week or 200 kilometers a week or whatever? All of those decision points come back to what are the athlete's limiting factors and how do we prepare the athlete to overcome those limiting factors? So this is kind of the meat of why I wanted to get you guys on the podcast, because if you're coming at this from the perspective that the limiting factor is the amount of energy expenditure, we can tailor training and interventions around that. At least I would think that we can tailor training around that very specifically. So with the group of, let's set up the study that you're doing right now, right? So the one that I am a participant in. How are you getting to try to solve some of this problem? Why don't you walk the listeners through what you're actually looking at and what you found to date so far?
Okay, so we started with Joe. Joe McConaughey ran the Arizona Trail about 800 miles, maybe a year and a half ago. And so we gave him the doubly labeled water dose, and we're able to, by collecting urine samples every day, throughout the course of that effort, he and his crew packed those on ice, sent them to Herman's lab. And we don't need to go into the details of doubly labeled water unless you want to, but basically able to sort of work backwards from the levels of the different isotopes in that doubly labeled water in those urine samples to figure out how many calories he was burning every day. So, and that worked really well. We got some numbers on Joe. We got some baseline data from Joe just during a 10-day period of normal life and training. We can talk about what we use that for later. And then we just expanded it a bit. I talked to Herman and we said, okay, how much money do we have to support this? We decided we can probably get data on maybe 10 to 12 ultra runners, over the next year or so. So this past summer, Joe actually helped us recruit some of you guys who ran the Cocodona 250. And I thought, man, what a perfect event. As ultras get longer and longer and more extreme, these are the people we really want to get. So we got all that data from 5 of you who ran Cocodona. We got some baseline data. I think one person, we still need to get that. We got race data, how many calories you folks were burning during the race. And I mean, going into it, I tempered my expectations and yours. I remember saying, okay, there's 5 of you. There's no way you're all going to finish this, because even in a 100 miler, what? I mean, I don't know what the dropout rate is, but I wouldn't expect 5 people to finish, Western states.
All 5. Yeah.
Right. Let alone, the Cocodona 250. So I'm watching the tracker, the live tracker. I'm like, these people are all going. This is incredible. So all of you finished. So we have, all the data from that. And then we just added one more data point. We're mostly kind of limited by my time. Honestly, that's why it's moving a bit slowly. So I got one of my buddies who set the record on the Appalachian Trail for the state of Massachusetts, where I live. The trail actually pretty much passes right by my office out there. And so we got his data from that effort. And so that's really the data set that we have at the moment. Hoping to add some more individuals this coming, next summer. So that's what we have. Do you want to hear?
Let me just interject because I want to kind of paint a picture of why we're going to this effort, right? So,
Yeah.
So we have basically from the study that we did in 2019, we have this metabolic ceiling that we proposed is the limit of human ability, that no human, this is the conjecture, this is the hypothesis, no human can break this ceiling, right? You can do whatever you want, but your body will shut you down before you can spend more calories for a given amount of time than you're sort of permitted to by this metabolic ceiling. And we came about that idea by looking back at the literature and some of the data that we'd collected on a couple of, this trans North American run. And those data kind of cobbled together, right, from different studies over the last few decades, from the Tour de France, from the Western States 100, from those kind of events. And, we kind of pieced this metabolic ceiling together. But as a scientist, that that's not the way you'd want to do it, right? What you'd want to do, if you really want to test this idea that there's a metabolic ceiling, is to, rather than going back in the literature and trying to find old data and put it together, kind of cobble it together, what you want to do is design the study, clear-eyed, looking forward and say, if this is the hypothesis, if this is the ceiling we think really exists for humans, how can we punch through it? Or how can we test it and see, prove ourselves wrong? Because that's what good science is, right? You're trying to prove yourself wrong. And so that's why we're going to all this trouble, because if anybody can punch through that ceiling, it's you guys. So that's what we're trying to go and measure with all the folks you're recruiting for this study.
And so what are you starting to find? Is that ceiling in fact a hard cap, or are you starting to find outliers or anything that makes you question the previous hypothesis?
I want to back up just for 30 seconds, if that's okay. I should probably describe how we estimated long-term metabolic scope, because we didn't measure that directly, right? So first, I'll answer your question just as a teaser, and then I'll go back and explain.
Yeah.
Yes, with the limited data that we've added so far, to Herman's ideas, we are seeing a limit. It seems to be around 2.5 times BMR. It's the same number that Herman's analysis found, and we're seeing that seems to be a limit still. So we're still.
So Herman doesn't have to rewrite his book yet.
Doesn't know.
You don't have to make it you don't have to append it in any way so far.
It seems
it's really boring. You guys are disappointing me. Science is more interesting when things don't work. But anyway, that's okay.
Okay, continue, Drew. Sorry.
Okay. So we have a couple data points from each of these runners, right? We have how many calories they are burning, really per mile for the Cocodona race and Joe's Arizona Trail and my friend's Appalachian Trail, et cetera. And the more data points we'll get, the better. And we have how many calories they're burning really per mile during their baseline training period. So I look back at their training logs and I say, okay, you were running, this was your training volume during that time. This was your total daily energy burn. So we can establish this relationship between how many, a person's total energy expenditure per day and how many miles they are running that day, right? So we're making a simple regression equation and then looking back through their training logs, which was fun to see how you guys train. I basically am able to estimate using that regression equation, cost per mile. What's the relationship between miles run and energy cost? How many calories you folks are burning for every month of a 12-month period that we looked at, looking backwards based on your training logs. So from that, we get a metabolic scope for every month. And, we could do this a bit differently. We could get a rolling metabolic scope and the results aren't that different. So we find that the 6 people we're looking at so far, I think we have training records and all that from 4 or 5 of you so far. Sustained metabolic scope averaged over a whole year is anywhere from 2.2 to 2.5 or 2.6. So even you guys who are doing this pretty intensive training, really intensive racing, you're living a really high octane lifestyle, fully supported by, ostensibly optimized nutrition, sleep, training strategies. Even you guys are not punching much above or at all above that 2.5-ish level.
And how is there any relationship between where you can consistently kind of like live at, whether it's 2 or 2.2 or 2.5 times your basal metabolic rate, and performance? Meaning, is it advantageous to live closer to that ceiling or further away or undulated? Have you found like any patterns with that, or is that an open question so far?
Open question. I would really hesitate to infer too much from this data set at this point. I mean, there have been a couple interesting things, but looking at only 4 or 5 people, does not make a robust study yet, as far as those questions go, making comparisons between the people in this group, right? But so sort of anecdotally, with the small sample size we have so far, we're seeing that the number of miles people are running in a given year, you guys, doesn't really have any relationship to the metabolic scope that you're sustaining. So I know I'm not directly answering your question, and we should come back to that. But so some people in our study so far seem to be running more miles at a lower metabolic scope, and a few of you are running more miles at a lower metabolic scope, and vice versa, whichever I didn't say, right? So basically, some people are doing more with less, right? Some people are training more at a relatively lower energy burn. Now, what we're not measuring are we have BMR estimated with a really good equation from Herman et al., but we're not measuring sort of non-exercise energy expenditures during these people's day. So it's possible. I mean, I asked all of you, is this the bulk of the physical activity you're doing? But maybe one of you is, kayaking an hour a day, didn't tell me. And,
trust me, as a coach, that happens. That happens all the time. People never update their training logs 100%. They always hide a few miles and a few activities in the background and don't sync their watch. So yeah, you're for sure getting that. So
that's why it's important to get a bigger data set, right?
Yeah.
I would say, that's exactly what I would. So we're too early to have, good training advice or anything to tell you guys that you don't already know, working with these athletes day in and day out. But here's what I think is really exciting about this research in terms of the way this could go. Why is it, if this 2.5, 2.6, whatever it is, if that 2.5-ish ceiling is there on how many calories you can burn every day, what happens as you get closer to it? Well, one possibility, we think, is that if you go past it, right, and you go past it for a long time, you're in overtraining world, right? And this is REDS, and this is overtraining syndrome, or whatever we want to call it now. And the symptoms you would predict. So remember, we started off saying it seems like your body can adjust. If you're more physically active, you spend less on other stuff, right? Well, what happens when you take it to the extreme? What happens when, not only are you not having inflammation anymore, but you've actually cut down your immune system activity so much that it's bad for you, and you aren't recovering from a cold, or you aren't recovering from whatever, right? What happens when your reproductive hormones don't just get kind of turned down a little bit in probably a healthy way, but actually get turned down so much that, you get hypogonadic overtraining syndrome, like Anthony Hackney's worked on. You get the classic female triad where women stop cycling, and so there are obviously kind of pathological consequences of spending so many of your calories on training that your body doesn't have enough calories to spend on all the other stuff it needs to do. And so we're kind of, I hope the utility of this work is we're going to be able to figure out where that is and help people understand it better, maybe be able to sort of structure their training better around that.
And I think that's probably the most relevant point for athletes to take home, is that there is a ceiling, a long-term ceiling, and at times you can eclipse it. Like you just mentioned, the Western States 100, Tour de France, you're going on a normal, training run and things like that. But when you look at things over a long-term perspective, months and years, this hard cap is something that needs to be adhered to. Otherwise, there are a myriad of deleterious things that can happen, and it's just not sustainable from any aspect, right? And you're coming at it from kind of the most fundamental evolutionary aspect. I want to dig into that a little bit more, but before we do so, I think we need to bring this into terms like almost a really practical, relevant experience in terms of what does that look like on a day-to-day training perspective. If somebody just goes out and does a training activity, what is that going to be to bring them to 2.5 to 2 to 2.6 times their basal metabolic rate? Just to make it practical. And I'm not saying nobody should ever eclipse that, but I just want, it's for a lay audience, getting that in their head is going to be very, very difficult. So what kind of training activity does that look like?
Sure. So this is going to vary across body types, across, if you're cycling on a road bike versus if you're running, miles. So this is going to be specific to you, but to put some kind of cartoon numbers on it, just to kind of ballpark what we're talking about here. A typical adult male's basal metabolic rate, let's say it's about 1,800 calories a day. Okay. So what's 2.5 times that is 36. It's about 4,500 calories a day, if I have that right. So that's the ceiling that you could burn pretty sustainably, let's say, as a kind of a ballpark, 4,500 calories a day. Well, if you've already burned 1,800 calories a day at just to rest, just as your baseline, plus, if you are eating 4,500 calories a day to stay in energy balance, you're going to be burning 450 of those calories just on digestion, right? So now we're at 2,200 calories a day as just minimal survival stuff. Now you need to you need to wake up in the morning, get out of bed, go, walk around, have your normal sort of daily life. You don't just jump out of bed and run, right? So there's other baseline stuff. Let's say you've got about 2,000 calories in that scenario-ish to play with. And that's a lot of training, right? I mean, a mile of running is something like 100 calories, something like that. Maybe it's more.
I just got my calculator out. So I was doing the math for you.
Yeah. So you can that's still a pretty high volume. And what I think what actually is that's missing is that I think that extra energy just to kind of walk around and have your daily life is probably too low. Remember that a typical guy in the US burns 3,000 calories a day doing almost nothing.
Right.
So maybe the limit on your exercise volume above that is more like 1,500 calories a day. But that's still a lot of volume.
It's still a lot of volume, but a lot of it, to kind of put a number on it, and I'm gonna back of the napkin in a little bit. It's anywhere between 40 and about 55 kilometers of flat level running for a normal adult size male. And when people hear that, they are going to know people who train more than that on a daily basis. And this is where it becomes quite interesting because it gets to the sustainability aspect of it, right? Yeah. What is enabling those people that we know have super high training volumes? Because those stories are out there. I train 200 miles a week. I train 300 kilometers a week, kind of every week for a decade. What could be enabling those people to actually do that? And they would be your best research subjects right there, because in theory, at least if you were to run simple math on it, they're eclipsing that ceiling.
Yeah. So I'll give you the physiology answer, then Drew will give you the more informed ultramarathoner answer. The physiology answer is that they really aren't breaking the ceiling. And so I work in, a lot of my work kind of bleeds over into the obesity field, right? You can imagine a lot of the work we do with metabolism and energy, a lot of this is relevant there. We do a lot of studies that are in that space. And what you learn is that people aren't very good at keeping track of what they do every day.
Yeah, that's true.
Right. So, they can't keep track of what they eat. They can't keep track of what they do, and not through any sort of malicious fault of their own. People are just bad at it. I'm sure I'm bad at it too. I'm sure we're all typical, right? And so my knee-jerk reaction to what you just said is they're not really doing the training volume.
Because they can't.
Because they can't, or they're doing it, 6 months of the year.
Yeah.
But they're kind of conveniently forgetting the fact that, for the other 4 or 5 months, it wasn't really that high. They couldn't do that. You know what I mean? For whatever reason, I had that week, I couldn't do this or that. Sure. Well, exactly. Anyway, that's my cynical physiology answer, and Drew might have a better real answer.
I am far less cynical, although I think something you just said makes sense. It is possible that, maybe they're going into serious debt, burning fat in muscle stores for a month or two at a time, and then they're repaying that debt by reducing training volume later, so that, over, say, a year, metabolic scope isn't much over 2.5 or so. But I anecdotally believe that there are people that train this much, and this is who I want to target for the next round of data collections. And I'm not sure I even want to limit it to ultra runners. Some of the shorter distance runners, cyclists, a couple of mountain bikers I know are putting in massive volume. So Jason's question, this is really the question that I'm already taking from this. What is enabling some people to perform at a higher level in terms of volume, in terms of training volume? Are they actually adhering to this limit? Is the limit for them higher, or are they doing more with less? Right. So I think there's really three possible answers. Well, there's four possible answers. One is Herman's, which is that actually people are not training as much. That if you pan out far enough, you're seeing where they're repaying those debts, right? Yeah. I think some people are doing that. And even if they're just total freaks, what is freaky about them, right? So number one thing that could explain how some people are doing more with less or less with more, maybe there's a lot of variation in the economy of movement, but running economy, well, that can vary, like 30%, but that's mostly about running faster at a given oxygen consumption, right? Not necessarily running farther. Yeah. So I don't think that variation explains it. Maybe there's one thing we haven't mentioned. Herman's work suggests that the ultimate limit, that actually sets the metabolic ceiling, is your ability to digest and assimilate calories. That it's really, how good are your intestines at absorbing macronutrients, and how good is your, liver and muscles at packing in glycogen? How good are you at storing, subcutaneous fat that's actually, accessible during activity? So digestion and assimilation. So if that's the limit, maybe there's a lot of variation between people in how many calories they can absorb. Mm-hmm. And, off the top of my head, I can think of some gross ways of potentially measuring this. Is there a way to measure basically energy extraction from food? Can you, I don't know.
There absolutely is.
Can you put feces in like a calorimeter or something and measure how much energy is left in the stool, right? I don't want to do that research. If I ever have a lab with graduate students, maybe that would be something they would do. I already deal with sweat and pee. I'm not dealing with poop too. So that maybe there's a lot of variation in this capacity of digestion. Maybe, I love to keep quoting the Ann Trayson quote, right? Ultra running is an eating event with some running thrown in, right? Maybe it really is, all other things being equal. If you've handled, your blisters, if you've developed your aerobic capacity, if, you have good maximal fat oxidation, whatever the things are, if you're able to really butt up against that limit, the metabolic limit, maybe the difference is, runner A can digest and assimilate more calories than runner B. So maybe that's it. And I think the third possibility is that there's variation in metabolic compensation. And this is an exciting direction that I could see us going in. Maybe there is a real metabolic ceiling, which we are seeing. And maybe the reason that some can do more with less is they're able to pull back more calories from other expenditures with or without side effects. Maybe the people who can run 150 miles a week are those who are able to really suppress, reproductive investment in terms of sex hormones. They're really suppressing, I don't know, immune function. You'd think there'd be side effects to all that stuff, but maybe there are people out there who can metabolically compensate way better than others and maintain, healthy physiology while they do it. And I don't think we've tested any of those things. I mean, Herman's work looking at metabolic compensation is really recent, last like 5 or 10 years. So a lot of questions still to look at there. But Jason, your point, how are some people doing so much? And are they breaking through that ceiling? That's the biggest question. And I just want to add, Jason, can I mention your data or no?
Yeah, please do.
Okay. In our small sample size, I'm just looking now, you have the highest sustained metabolic scope of 2.6. So
just over the edge.
Yeah.
Maybe I was just overtraining for a whole year. Was that
it's a whole year. I mean, this is May 2021 through April 2022, based on the training records that you provided me. You're burning on average 4,900 calories a day for 365 days. Your metabolic scope is 2.6. Your training volume was pretty big, but not the biggest. The guy with the biggest training volume here, he ran 4,500 miles in that year, something like that, had the second lowest metabolic scope. So there's something happening here. There's some variation here that needs to be explained. And when it is, it'll have applications to, Herman's ideas about the evolution of human metabolism and what constrains it, but also ultra runners. I mean, in a couple of years, I think we'll be able to hopefully actually have some insight into what is this variation? How can you tweak it? How can you train to it? Maybe I'm getting a little ahead of myself, but.
Well, once again, I mean, if I think about it from a training intervention standpoint, I look at this research through a really broad and long lens that tells me that there is an upper limit to how much training volume somebody can sustain over the course of 1 or 2 or 4 years. And I happen to be very privileged that most of the athletes that I work with, I have relationships with for many, many, many years. And having that scope, having a metabolic scope, if they've only got so much budget that they can work with over those long time frames, yes, you can spend a little bit more than you're taking in for certain amounts of time, but you have to repay that in some organized fashion. And training architecture, in my observation and in my philosophy, training architecture should revolve around should partially revolve around that cornerstone of how much energy that you want to expend to maximize the adaptation for certain periods of time. And then when those periods of time aren't as important, you can come back and you can repay that debt, so to speak. So this is why this is kind of like fascinating to me. And yes, it's a little bit esoteric right now. I was trying to pin some numbers down and it's still, very, very, very fuzzy. But to me, it's extremely enlightening because it comes back to this overall philosophy of, yes, you can, burn it at two ends, but you're going to have to repay it at some point. And when you broaden the lens out far enough, you can see those undulations in people's training and how to make it the most effective possible.
Yeah.
I think that's a great way to leave it. Is there anything else that you guys want to leave the listeners with? Can they participate in the studies or any pieces of advice on how to look at this in order to inform their own training?
I'll jump in right now. We're doing a study in a sort of parallel to the one that Drew's leading. My lab is working on what these energy limits look like in women. So women athletes who are putting in high training volumes. We're focused specifically on runners because that's a well-known mechanically and energetically understood exercise. So if you're a female athlete, you are putting in lots of training through a pregnancy, right? We're focused on the pregnancy aspect of this. And you're planning on, we're not asking anybody to do anything they're not already planning to do. But if you're planning to maintain a high level of running through pregnancy, then let us know, because we are recruiting for that study right now. We've already had about 10 athletes through. who've had successful pregnancies, and we've measured their energy expenditures through, all 3 trimesters. And to watch that data come in is exciting. And I can't spoil it now. I don't know. We don't have enough to say anything yet, but it's been going really well. And it's another way to kind of test this limit. And it has obvious implications too for, half of the world out there who needs to be active and wants to stay active, potentially through a pregnancy. It's an area we don't know much about in reproductive health. Is if you're a high volume athlete going through pregnancy, how do you manage that? What does that do to your body? So it's got theoretical applications to the kind of stuff we're curious about. It's got, I think, really real world health applications to women who are, women athletes who are thinking about pregnancy. So if that's you, send me an email and we'll get you involved in that study. And if you are just, a typical ultramarathon runner who isn't going to go through pregnancy like that, get a hold of Drew and we'll recruit right now.
I'll leave that link in the show notes for anybody who's interested. Drew, do you want to tack onto that at all?
I mean, the only thing I would tack on, and Herman and I haven't explicitly discussed it, but I would like to look, with the remaining funding we have for this coming summer, maybe 5 more people. I want to find really high volume athletes. So I think I ran with him yesterday. I think I've maybe pegged down one of my buddies. So that would leave 4. If you're doing like well over 100 miles a week pretty consistently, if you're a cyclist and you're putting in, 20 plus hours a week, you are the people that I want to see now. I don't care how fast you are. It might even be great if we had a spectrum of faster and slower performers, but if you're putting in really huge volume, I want to see why. I want to see if you're able to bust through that ceiling, and if not, why not? So be in touch.
And I'll leave that link to in the show notes as well. You're going to have some people that listen to this podcast that are running over 100 miles a week that are going to want to test it, because if we know anything about ultramarathoners and ultra endurance athletes, they want to see and they want to know if they are the anomaly. If for no other reason, just to be the anomaly. It's part of the attraction of the sport.
People always, since that paper in 2019 came out where we sort of proposed this metabolic ceiling, I've had so many people reach out, and either they want to test to see if they can break through the ceiling,
of course,
which is awesome. Let's do that. Or people say, aren't you going to be so disappointed? How are you going to feel when somebody breaks your pretty little hypothesis, And I'm like, man, you don't get it. That would make me so happy. That would be awesome. So please come destroy this beautiful idea, because that's how science moves forward.
Challenge accepted and gauntlet throw down. I hope that you guys get any number of inquiries from this podcast. Thank you guys for being on. I really appreciate it. Like I said to the listeners, everybody out there right now, give these 2 a follow. If you are interested in the research that they're doing, hit it up in the show notes. Those of you on the YouTube version can see Herman's book, Burn. It's a fascinating book. It's very intriguing, and will definitely get your definitely get you thinking. I'll leave a link to Herman's book in the show notes as well. Thank you guys for coming on the podcast. I appreciate it a lot.
Thank you.
Thank you, Jason. Thank you, Herman.
All right, folks. There you have it. There you go. Much thanks to Herman and Andrew for coming on the podcast today, and more importantly, for the research and the work that you do in the field, and especially challenging some of our notions about human metabolism and how we got to where we got. I certainly have thought a lot differently about this subject since first encountering Herman's work, and I've come to appreciate how difficult some of this research actually is to conduct by being a subject in Andrew's research project that we discussed during the podcast. So thank you to the both of you. If you want to get involved in either of their works or just learn a little bit more about them, there are a ton of links in the show notes. Y'all go and please check those out. Thank you to each and every one of you that are listening to this podcast. As always, this podcast is coming to you unsponsored. I don't have anything to shill you. I'm not going to sell you any affiliate codes or athletic greens or Aura rings or Whoop straps for 20% off or anything like that. And I don't do that in order to make the content within this podcast as unadulterated and unfiltered as possible, because I believe that serves you, the end user, the best if I do not have those restraints. So you can help this podcast out tremendously simply by sharing it with your friends and your training partners, and helping to get the word out about all of the incredible content that this podcast brings to you week in and week out. That is it for today, folks. As always, we will see you out on the trails.